We'll wait a couple of minutes for people to get in. Yeah, in the meanwhile, maybe we can start by saying a couple of words about ourselves for the people who don't know us. So my name is Sergi Castella. I'm the AI community manager at Zeta Alpha, and I try to stay up to date with what's happening in the AI world. And every month we do this blog post and this webinar to sort of talk about what are trends and things that pop up in the world of artificial intelligence. Jakub, what is your role at Zeta Alpha?
Well, I started it, so it's all my fault, and I'm pretty excited about the recent developments in AI. I've been excited about them for the last 30 years, and I think AI researchers need AI assistants to help them stay on top of this development. So that's what we're building. But while we're building that, I think Sergi and a bit of human touch helps make sense of it.
Yeah, that's what we
welcome to our show.
Definitely hope. Marzi?
Hello everyone. I'm Marzi Sadai, and here at Zeta Alpha, I'm the lead for the NLP research that we are doing. And as always, I'm very excited about our monthly talk. And I do really like this meta level up, but the product that we have is something that we also use for our own research and also for our own research for the webinar. And this loop of improving our product helps us ourselves as well. So very excited to discuss that today.
All right.
So at a certain moment, this talk show will be done by bots, but we're not there yet.
We are on our way.
Not sure if that's good news or bad news, but anyway,
we will be in Barcelona, right?
Yeah, that's for sure. Yeah, so we have a lot of stuff to talk about, so I would like to start already. So I think, Jakub, you have a couple of words you want to say before we jump into the research stuff.
Yeah, we always like to start this monthly show, well, first of all, by welcoming you, and second, by reviewing some recent news. So the onslaught of large numbers investments in AI is going on and on. I think it doesn't seem to peak anywhere. So Spark Cognition, for example, and a couple other companies raised very large investments. Wave, which is the UK-based self-driving car, they're kind of doing end-to-end reinforcement learning for self-driving cars. Very interesting approach. 200 million. InstaDeep from Tunisia, well, Tunisia and London, they raised 100 million. If you're wondering what's InstaDeep, they are the guys who developed together with BioNTech a machine learning based warning system that sequences the genome of the COVID virus and determines whether a certain variant is risky or not. So they raised 100 million. Congratulations. And I saw this little snippet. Mustafa Sulaiman is going into venture capital with Greylock, looking for the AI's next best thing. If you're wondering who's Mustafa Sulaiman, Sergi, do you know?
I don't actually, no.
Well, Marzi?
No.
He's the co-founder of DeepMind.
Oh, wow.
So he started DeepMind and together with Demis Hassabis sold it to Google. And if the rumors are true, he got fired for being very aggressive and obnoxious towards his researchers. So I think maybe in a venture cap, it's rumors, but maybe in a venture capital role that style is more befitting. So in other news in AI, I saw this one this week. Cruise, daughter of General Motors, launches a public waitlist for robo-taxis in San Francisco. So after Waymo, there'll be another fully driverless vehicle picking up passengers in San Francisco. Think like, wow, self-driving cars are a little bit closer than we thought, right? Sergi, what did you say? What was your bet?
I think it was 5 to 10 years for something like that.
Yeah. So
for level 4 or
yeah, for level 4.
level 4 is almost always unassisted, right?
Yeah.
So yeah, Cruise is doing a good job. But if you read this sort of sideline, well, because they applied for this permit and got it, SoftBank invests another almost $1.5 billion. So I think they pushed pretty hard to get the permit. So we'll see how that goes. Certainly, they landed also huge investment. So what else is in the news? Sergi, you noticed this one?
Yeah, absolutely. This is the Facebook's announcement of this new supercomputer, which I think is kind of nice because it exemplifies that this trend of using like a compute-heavy artificial intelligence is here to stay, and big players like Facebook are betting on it really hard. So I guess that's only getting more accentuated.
Yeah, and it's full of NVIDIA DGX stations actually. I find that interesting because it means that they're actually not betting on any of the sort of new chip vendors in AI like Cerebras and GraphCore, just going with the good old NVIDIA GPUs. Well, I guess that makes sense. Margie, how many of these GPUs would you like to have for your experiments?
I mean, it's never enough, right? The more the merrier.
6,000. Well, I think a dozen would do for us, maybe. But these models are getting larger and larger. We'll come back to that. So that's our Facebook. I think we want to sing a little song for Facebook. Happy birthday.
Yeah. PyTorch 5th anniversary, right? I think it's been really interesting because we have kind of lived through this transition where PyTorch went from this, like research niche. Everyone, like a lot of people loves it, but it's still like not ready for a lot of applications into like the big mainstream. Do you remember the older days of PyTorch, Marzi?
Yeah, I remember the excitement of finally leaving PyTorch behind and using PyTorch. That was really a true turning moment.
Yeah, I think it's downhill for TensorFlow. You really see that. This is a graph from like mention of the concept in all the research papers. Okay, so it's research papers. It's maybe not internal code repositories in large enterprise, but this is really like a very strong signal. Although the next thing might come around. How about JAX or pedal? Well, we'll make
For a lot of people excited about that, but it's still not mainstream for sure.
So more news. A lot of news came out in kind of last month or so. Some pretty big announcements from OpenAI. So OpenAI introduced a service for embedding text for like retrieval search purposes. So Marzi, you're going to talk about that a little bit more, right?
Yeah, I don't want to spoil it a lot, but in a few minutes we are going to discuss both the paper.
They say it's pretty good. We'll hear about that in a moment.
Yeah, discuss both the paper and also the controversy around it.
Yeah, and another big announcement, the aligned language models. So really changing GPT. I think they changed the production model of GPT in the service, that it's now able to follow instructions. So you say something like write a story about about a girl and a wolf, it will write Little Red Riding Hood right there for you without needing to invent a really clever prompt. What do you think, Sergi?
No, it's really interesting. I think it goes very much in line with other works from like DeepMind and all of these retrieval enhanced models that seek to not only create nice sounding text, but like factually accurate and more robust to different data distributions. So that's definitely a step in the right direction.
And there's also just 2 days ago, they announced that they had trained a network to solve math Olympiad problems. And kind of in line with that, DeepMind published this paper AlphaCode, where they say that they are able to do better than about half of the competitive programmers in some common benchmark for competitive programming. So that's AlphaCode. In other news, kind of, maybe not so relevant anymore, but who remembers IBM Watson? Well, they won Jeopardy. It was the start of kind of the AI coming into the mainstream. Now they're giving up on their whole health Watson thing, selling it off to private equity, still for $1 billion. So assuming they have some customers and stuff, but it's an end of an era. Who uses IBM Watson services? Not so many, I think, in the kind of open source academic world. For European research, really big news yesterday, I think it was announced yesterday. So there's this ALICE network, a network of excellence in AI all across Europe. They got 100 million euro, that's more than $100 million, from SAP co-founder Hans-Werner Hector's private foundation to build a really large research institute in Tübingen under the direction of Bernhard Schulkopf. So congratulations for that. I think that's a big deal for European AI. And in somewhat smaller news from Zeta Alpha, the papers, accepted papers from iClear 22 have been announced, and we immediately index them. So you can search for the accepted papers, and everything from iClear has been, of course, on the web for a while as anonymous papers, but now you know who's who. And the little cluster visualization you see, that's from our platform. So that's all the papers in iClear, so you can browse them in our platform. And for those of you who have not seen our platform before, that's our product and what we actually build every day. So a navigation and discovery tool for AI and data science teams. And I won't talk for a long time about it, but in Zeta Alpha, you can basically discover content and people using neural search and classical search, find similar work or related work, visualize paper collections like iClear, and find out what's trending on social media and what's trending on GitHub, and then organize it in your personalized collection using tags, and that will start recommendations for you to keep you up to date. And because we are lazy and we like to keep things efficient, that's actually kind of what we're doing for this monthly series. We're looking what's trending and looking what's relevant for our interests.
Precisely, yeah. I mean, the workflow is pretty much, I keep checking my recommendations and I just keep adding the papers that I find interesting. Then at the end of the month, we do a bit of a filtering on that list. So, you know, part of the work is done by the platform.
So this is, I think, not iClear, but this is actually the harvest of January of the last 31 days.
Mm-hmm.
So yes, Sergi, you are the chef. You picked out the best bits of it.
Yeah, exactly. So if you can read in our blog this latest piece I wrote this week about recent papers. This is a visualization where you can see some popular stuff like these ConvNets for the 2020s that we're going to talk in a second. And I would say let's just jump into it. There's quite a lot of stuff that I want to talk about. So the first quick stop that I wanted to do was in the reinforcement learning category. There's this paper, this survey actually called Automated Reinforcement Learning AutoRL, a survey of open problems. And the reason I chose this paper is, well, I believe that, you know, the whole world of reinforcement learning and machine learning are still quite sort of isolated spaces, although, you know, the big conference, NeurIPS, iClear, some of these share sort of the venue, the sort of vocabularies and techniques that people are using are quite differentiated. And this kind of survey is really interesting in sort of being an entry point for whoever wants to, get familiar with the terminology that people in reinforcement learning are using. And you might have heard of this term called AutoML, which is this sort of whole idea of wanting to automatize as much as possible in the process of building ML algorithms, with the goal that you don't need to, with the goal of making people who are not experts being able to use these machine learning algorithms. And this is a very interesting sort of analog in the reinforcement learning world.
Look, without hands.
Yeah, well, I mean that's a promise, but I there's a lot of skepticism in this, because at the end of the day, a lot of the success in the machine learning and the reinforcement world comes from very skilled people who know what knobs to tune to, to what degree particularly. And I like the dream of things that work out of the box is still quite far away, but it's good news that people are trying, at least in my opinion. And the other one that I wanted to highlight is not really a reinforcement learning paper, so it's a bit of cheating, but I found it was quite interesting because it's sort of basically uses language models to solve a planning task, which is normally framed as a reinforcement learning problem. And they show how you can use pre-trained frozen language models to cleverly combine them into converting high-level tasks like cook an omelette into low-level actions like go to the fridge, get the eggs, break the eggs, do this, do that. And I think that's a very interesting direction, because it's a very open-ended, and it uses like the knowledge that is kind of in these large language models only by their pre-training, which is still like an area that is being explored.
Yeah, and if you go to this, they have a website, right?
Yeah, they have a website with
all these funny videos. This guy walking around in the simulation world.
Yeah,
he's actually executing the plan that's created by these GPT-3 like storytellers.
Exactly, and a lot of their experiments, they don't do any fine tuning. They use just pre-trained models on not a planning task, but a language modeling task, which is interesting because it's like repurposing these models for stuff that they were not designed for.
And I think if you also look at it as, so in the area of reinforcement learning, a lot of times they have been focused on templates as instructions and not really natural language that you cannot control what it's going to be look like. So it's really interesting that finally language models are getting used in this area, so that it takes the toy examples really to a next level.
Yeah, I think it's interesting. Like if you look at reinforcement learning, it's obviously trying to learn a policy or a plan just from success. But if you look at language, there's a lot of common sense and relationships that you can use to inform that plan. And I think this paper, maybe not earth-shattering, but it kind of nicely shows that background knowledge in the form of large language corpora is very relevant to planning.
Absolutely. So if we go to the move on to the next slide, I feel like this is becoming a very thing that I'm really interested in personally, which is this whole space of combining language models with some sort of explicit retrieval. There's been some papers by DeepMind and OpenAI recently that propose models like this, but there's other people who are working on this. For instance, knowledge-infused decoding is an iClear paper. More recent, and this is sort of a topic where I wanted to bring attention to. One of the papers that is in this sort of topic is this LaMDA that Google released. Jakob, what does this paper do, and what do you find interesting about it?
Yeah, so personally, I have a strong belief that the future of AI will be conversational, right? It's interactive systems, not one-way communication. So chatbots, dialogue, and this paper, LaMDA, it came out 21st of January, is a really good read. So if you care about this area, definitely a strong recommended read. It has 57 authors, and among them are various let's say, AI rock stars like Kwok Lei and Noam Shazir and Daniel De Freitas, and Ray Kurzweil, not to forget. Yeah, really impressive paper. Long read, but very much worth it. And what is LaMDA? So LaMDA is basically a very large language model, 137 billion parameter transformer with this kind of retrieval augmentation. So it looks up things in a search engine, and that helps to keep it more like grounded, to make the dialogue more factual and more correct. And I think actually a lot of other chatbots has also been using that, and it's a very common practice in sort of open domain question answering, of course.
Yeah, exactly.
It's a huge model. So they've been training for 58 days on 1,000 modern TPUs on 1.5 trillion words of public dialogue. Well, actually, it's not all dialogue. It's also code and some like the pile and some, web corpora. But there's a lot of dialogue there. So that builds this pre-trained model, which is huge, and it's a follow-up on this earlier paper, which was called MENA, which came out about 2 years ago, and that model had 2.5 billion parameters, was trained on 40 billion words. So this model is like 40 to 50 times bigger, and that model, the MENA, already was pretty close to human performance in terms of sensibleness and specificity, which were kind of the metrics that they introduced. And so now this paper, LaMDA, adds to that interestingness, right? So something can be very specific and very sensible, but still be very boring. Like, that's right. Okay, it's not a very good continuation of dialogue. So LaMDA looks at informativeness, but also at two other things. It's safety and groundedness. And actually on this SSI measure, it matches human performance. On safety and groundedness, not so much. So it can still hallucinate or say things that are slightly off the rails, but it's getting close. And how do they do that? So basically, they fine-tune this very large pre-trained model on a little bit of dialogue data, which has been labeled by humans to be informative or safe or correctly grounded, and that helps a lot. You see that in this upper right-hand corner. That this is how they reach this sort of human level on SSI.
Yeah, I have to say that one of the reasons that conversational AI piques my interest is ever since I've used any chatbots or stuff, I've always been frustrated, and I really, really hope that the underlying technology really gets better, so that finally the cities and the Alexas of the world kind of deliver on their promise. Their original promise.
Of course, the dialogues in the paper are kind of cherry-picked, right? Yeah. But this is an example. When did Yuri Gagarin land on the moon? And then it really goes into like to give you the facts. He was not on the moon, but then in the end it stumbles. It's like, well, yeah, he brought back moon rock samples from when he got to the moon. Well, okay, so it's not 100% yet, but maybe it's a joke. I don't know. So one thing that I do want to point out is that this is a paper from Google, but very long paper. There's no mention of where you can get the data and where you can get the code. So if you want to play around with it, Sergi.
I think that's a very good segue to the next section, which is this API publishing of language models and models by these big companies.
So if you want to play with chatbots, I think the Blender bot also uses retrieval augmentation and a lot of these tricks. It's actually a better choice. It's open source. It's from Facebook. Not that I'm a particularly big fan of Facebook, but they do open source all their stuff. Before we move to your section, just wanted to mention these. If you're interested in conversational AI, there's these two books on archive, complete introductory textbooks on conversational information retrieval and information seeking, definitely worth checking out if you want to get into this area.
So the next paper we have is a dataset paper that Marzi read and is gonna talk about a little bit. And the reason I chose this one is, you know, a lot of these shifts in sort of trends in machine learning, where there's a lot of models doing a certain thing, usually go hand in hand with the introduction of benchmarks to measure those things, because it's kind of really important to have good measurement systems for whatever you're developing. So Marzi, what does this paper propose, and yeah, how does it build on previous work?
Yeah, so it's a very interesting paper. So I think our longtime audiences know that I'm very much a fan of benchmarks, and I think like working on existing benchmarks are really nice and important, but as the models are getting better, we do need new benchmarks, more complicated tasks, more complex tasks, so that we can actually evaluate these new and shiny models that come on in a more fair way. And this paper is an example of that. So there is the KILT benchmark, which is on knowledge intensive NLP that came out in 2020. And this paper is a continuation of that and making it a bit more complex. So it addresses a number of challenges that exist in open domain NLP tasks, basically like question answering. And those are having a knowledge that is like web scale, what they say, like as big as possible. The knowledge can be without any structure, and the quality can be inconsistent and full of noise. So the existing KILT benchmark, it uses Wikipedia articles as its knowledge source. And as you know, Wikipedia, if not perfect, it's still structured, less noisy. What they propose in this paper is to replace Wikipedia articles with a snapshot of web, basically. So I think what they call it is sphere corpus, which in terms of size is also much larger than Wikipedia. So going from 6 million to 134 million documents or articles. And also in terms of noisiness, it's inconsistent because it's web articles. And what they show is that here you also see in the table that existing models, how they perform on Wikipedia and how they perform on Sphere is really different. So once you have this much larger, much noisier source of knowledge, which is more realistic, the existing models performance expectedly go down. So it's like a new challenge for people that work in this area.
It's kind of a little bit ironic, I feel, that normally when people talk about preparing, the importance of preparing a data set and cleaning up your data and having good labels, and I feel like in this data set, it's a little bit the opposite direction, where having noise in your corpus is actually well, not a feature, but is kind of a challenge that is interesting to overcome, right?
Yeah, exactly. So it's like going the other direction, try to have as much of a realistic setting as you can get.
Yeah, yeah. So we'll see if the benchmark picks up. Sorry?
Yeah, I do want just to add that they do have some analysis on how the existing BM25 and DPR, which is a dense retrieval model, work on their data sets. So if people are working in that area, this is also a good example of how traditional retrieval and dense models can work with this knowledge intensive and noisy collection.
We jump into the next topic now. Finally, it's this, Jakob already hinted at this. It's the topic of language models as a service. This is something that came up also in our previous webinar. And it's basically this thing that a lot of big language models coming from corporations like OpenAI or Google are not fully open sourced, but instead given access via an API. And this is becoming a trend, and I only expect this to become even a larger trend. And the main reasons that I can think of that why this is happening is first a practical one. When you have a a GPT whatever like model, maybe the weights are terabytes, so it's not really feasible to download them and build a cluster to to run inference on these things. So it's like useful to abstract away the implementation aspects of that. But secondly, and perhaps more importantly, is that the companies like OpenAI are starting to rely on these as a very valuable intellectual property. So it's a very good advantage for them to keep it in-house and not open source it. So I think that's a very interesting sort of trend happening. And
you
where
still
does
have to guess the right prompts, right?
exactly
To make it do what you want.
So what the paper that I wanted to highlight is this black box tuning for language models as a service, because it sort of assumes this premise of, okay, we only have access to a certain language model via an API, so we can only query it with a certain input. And then they ask the question, how can we optimize this model to solve a task that we want to solve? And they propose this clever algorithm that basically does like a dimensionality reduction to search in a low dimensional space, continuous prompts, and then optimize with a certain number. Let's say you can only make 60 prompts to 60 queries to this API, and optimize these continuous prompt such that the performance is the best possible given a small budget of how many times you can try. And it's kind of interesting because you cannot apply gradient descent methods because you don't get gradients from an API. You just get the inferences from this black box API. So it's a very interesting different setting that is going to become, I think, more and more relevant as these models as APIs become the norm in a lot of places. And yeah, and a couple of sort of points that I wanted to highlight is this idea that more and more we're seeing how building machine learning software is decoupled from the idea of training models. It used to be sort of a synonym that whenever you were building some ML software, you were going to train some model, and it's becoming more and more common that you just get other pre-trained models and combine these things as sort of building blocks for algorithms that you're working on. And I think that's very an interesting sort of conceptual shift.
Absolutely.
And we'll see how this evolves. And this other paper that we're highlighting here is this coming from the Big Science Initiative, spearheaded by Hugging Face, where they're proposing, they're introducing this framework for doing prompt tuning with natural language. And I think this only is an example of how prompting is sort of becoming more of an established technique in the NLP world.
I said the future is conversational, so you're gonna try some starting lines. As long as it doesn't give you what you want, you continue the dialogue.
Well, I mean, at a certain level, you could argue that's what we're doing when you talk to people, right? That might be a bit of a stretch.
Don't do what you want, you just talk to other people.
All right, so this leads us to actually a very interesting example of a model that is exposed as an API, right, by OpenAI. There was this announcement of this model that you can use if you pay, and they're gonna do some. They're gonna calculate embeddings for you, but you're not gonna see what's
very large embeddings.
Yeah, very large embeddings.
12,000 dimensional embeddings. Wow.
Exactly. So Marcy, what is the what's the core of what's the meat of this paper, like the core substance?
So it's a good follow-up of what you were saying about language models as service. So the positive is that these sorts of services make these models more accessible to people with less knowledge of actually training and deploying these models. But also on the negative side, the transparency of how these models were trained, what data they were using is not completely there. And when you have papers on these, then you have these questions, and analyzing that is hard. So maybe let's first talk about the paper itself. So yeah, this is, like you said, the embedding API introduced by OpenAI, both for text and for code. And the idea, so the core idea is that they take a pre-trained generative language model, and then they train it with the objective of basically a contrastive learning objective. So for their text embedding, they treat positive samples as texts that are near each other, and the negatives are just in batch. So basically everything else is negative in a batch. And for the code, it's also a bit similar. So for training the code embedding, they take the docstring, the top level docstring of the code, and the implementation as the pairs. So they basically train these models with 3 different sizes. So here you also see the sizes, small, medium, 4 actually, small, medium, large, and X large. They report 4 or 3 at different tables. And what they do is evaluate. So they basically have this bioencoder, and for each input they get 1 embedding. So for a document or sentence or whatever the task is. And then they evaluate the quality of these embeddings on 3 different tasks. So sentence similarity task, retrieval task, and zero-shot retrieval task. And what they show in the paper is that on retrieval and zero-shot retrieval, which is the Beer benchmark, they get some improvements. On sentence similarity, they don't. So I know there are a lot of numbers here, but it's worth looking into these numbers, I think. So maybe let's start with the sentence similarity task. So the argument, which I'm also partial to be honest, is that sentence similarity is a very vaguely defined task. So what and how you define relevant and similar as 2 pairs of sentences can vary from data set to data set, and it might not be the best task to capture what they are doing, but nevertheless, they still report that. However, on the retrieval and the Beer benchmark, you see some improvements there. But when you look at the difference of improvements, like actually how much you gain with each of these models, like the most gain clearly comes from the X large model, so the most largest model. But what goes into that in terms of the number of parameters, in terms of the cost of actually doing that money-wise, and also like things like memory. So one thing they mention is that it's very critical to have a large batch to train this, and for that you need large machines, big memories. So how accessible this is for everyone, that's also another open question.
So one of the questions that that I have looking at this paper is, does this provide any new insight on this sort of fully unsupervised information retrieval space? And is it sort of a hopeful one or a negative one when compared to using, some labeled data?
Yeah, so that's a interesting question, Sergi, because we are actually also working on unsupervised retrieval coincidentally, and we are also using GPT-3. So a little bit of a sneak preview for everyone in the audience. Next week, we will have our paper out. And I think it boils down to how you use them. So not really that there is like any way that you use these models, you can get great results. But another thing that I want to mention is that
I think you have better results than this, right?
We do, yeah.
Oh, exciting!
Yeah. But like you said, so when we say unsupervised, it's so the CPT text model, for instance, it's not entirely clear how. So they also say it's unsupervised, but we also know that it's trained on everything in the world, right? So like how it use these existing IR data sets and how we can trust that. So it's a bit of an open question.
Yeah.
So yeah, if you actually go to the next slide, there has been some discussion about this paper online. So Niels from Hugging Face actually posted a very interesting blog post that analyzes the results. So in his blog post, you can see that so clearly this, on the sentence similarity task, much older, like 2018 models, or much simpler, smaller models, they perform better than what this paper proposes. And even when you look at the Beer benchmark, in the data sets that the paper didn't report, but Niels actually runs the experiments, he sees that the when you look at the cost versus the performance, it's not really a question of who is the winner here. So yeah, it's very debatable how or who these models are going to be targeting. But I think if you are going to pay this much, you probably also would like to get performance that is much nicer than existing publicly available models.
Yeah. So
I'm so excited for your paper, Marzi. I think I will get it in my recommendations from Zeta Alpha very soon. Well, we'll see.
Probably me too. Me too. Before we jump into the next paper, I wanted to ask you about. So I get the sense from this paper that one of their sort of overarching sort of motivations was this idea of building embeddings that are like embeddings that are good for everything, or like an embedding to rule them all, or something like that. So my question is, how optimistic are you about this sort of direction of having a single representation that is good for, you know, retrieval, NLP tasks in general? Like, do you think is a too optimistic thing to direction, or do you think that you know, it's gonna be a successful one?
Yeah, I mean, having an embedding to rule them all, I think from the Middle Earth experience that it's not going to end well, or it's not going to be the answer. But yeah, that's a good question. So I think, like, in principle, learning, like having one representation that captures the meaning that you have in your text is like really nice and valid. But more and more we see that it's very subjective what is relevant meaning. It depends on the task, on the downstream task. It depends on how much information is in the text and whether it makes sense to encode it in one embedding or not. So I'm not really betting on that, to be honest. I think in some cases it can be useful. So it's definitely a much simpler and like fastest way of encoding something into just one representation and do like search, retrieval, or classification, or whatever you want to do with it. But if you want to like really look into the capturing the essence of the text, and also then it working out with multiple tasks across the board, then probably it's a bit too simplistic.
To keep a close eye to see how that you know, develops in the next years.
The unsupervised learning is a very large part of that, right? Of deriving these things, because MS Marco is a unique thing, but it only exists for kind of one task.
Yeah.
Nobody has so much supervised training data.
Yeah, definitely. Like the focus on self-supervised and unsupervised approaches in the past 2 years, especially, I think that really shows how, like where everyone should invest their time on and where the gains are going to be.
So it's already a bit late, so I would like to shift our attention to a non-NLP heavy topic, which is computer vision. So ConvNets were back in the news this past month. Why is that, Jakub?
Yeah, so this was a paper which appeared beginning of January, a ConvNet for the roaring 2020s. I think that was the idea.
Yeah.
From a couple of people from Facebook and Berkeley AI. There's a kind of missing author on the author list. He is actually mentioned in the acknowledgements. That's of course Jan LeCun. the concept of this paper was that actually convolutional neural network, like last year was the year of vision transformers, right? I mean, we covered a lot of them, Swin transformer and VIT and Barlow twins and all these new things. And it seems like transformers have completely taken over computer vision. And it's amazing because it's really an architecture that was started in NLP and it's kind of without a lot of changes being transferred to computer vision. But the argument made in this paper is that actually the transformer has a lot of tricks, like from the training schema, from the stride size, various kind of activation functions, and the transformer is just more optimized, really. So what they do in this paper is they try to kind of backport all these optimizations onto the ConvNet, and you see that in sort of this left chart here, and then you see that they are actually able to somewhat beat the Swin transformer, which they consider the state of the art on ImageNet top 1 accuracy, with something like 82 against 81 on top 1 accuracy. And they say, well, ConvNet is back, you just need to optimize it better, and there's like a good inductive bias in convolutional neural networks for computer vision.
Yeah, so I feel like I have a mixed feelings about this. I feel like I live a little bit more confused than I was, even because after all this year of this past year of seeing transformers, MLPs, ConvNets applied to computer vision, it does seem like at the end of the day everything works kind of.
Well.
If you put it well
certainly,
enough.
if you want to use ConvNets for computer vision, this ConvNext, as they call it, which they introduced in this paper, is open source on GitHub. It's a good choice, right? It's better than all the previous ones. But what they kind of leave out is that actually there have been other papers like this co-attention net, which is kind of combining convolution and attention in a more elegant way, and that actually has about 90 on ImageNet's top 1. So really, Swin transformer is not the state of the art. This other sort of more recent work is the state of the art. And I think they're also kind of shuffling a couple other things on the table. And it's so nice of today's scientific discussion that Twitter is such an open, like fact-checking platform, basically, for science, right? So just as they published this paper with this little sort of suggestive graph that they are now the kings of the hill, a couple of people made, like Lucas Bayer, one of the authors of the original vision transformer, said, well, what we didn't do was data augmentation. If you do data augmentation with the vision transformer, actually it's more like where the green dot is here. And Ming-Ching Tan says, well, actually they kind of forgot to mention efficient net version 2, which has really been a lot better already for a long time. So it's a good paper, worth reading, and kind of mainly sharpens your awareness of state-of-the-art optimization tricks.
Yeah.
And I think these tweets also show the importance of doing your literature review, like having a tool that you can do your literature review really well.
True. Yeah, we're there for that.
Absolutely. Okay, so the next, very quickly, because we don't have a lot of time, I wanted to briefly mention this trend of multimodal models. We have seen these also for the past year or so, and lately there's been these couple models from Facebook, causal masked multimodal model of the internet, where they basically use HTML data and encode images as as VQ, VAE dictionaries. This is basically what they do with DALL-E, which is basically you learn like discrete tokens for image patches so that you can generate them outer aggressively, and they train this model with this. And then there's also this audio and image and basically modality agnostic technique that Facebook proposed with data2vec, and I think this is a very interesting direction to sort of have one one method to learn from different modalities. Still, I think it's a very interesting question to ask. To what degree is going to be useful, because in a lot of the benchmarks that exist nowadays, these models still don't outperform the unimodal counterparts. So I get sometimes a bit of a sense of a solution looking for a problem to solve thing with these papers, and we still haven't figured out.
I would argue that we humans are pretty multimodal as well, and it
Yeah, I mean, the
helps
motivation
us
is
in
clear.
many way, right? Like if I remove the video from Zoom, you can still hear me, and that kind of helps.
Yeah.
So and one other thing with relation to the previous paper, really the fact that transformer is kind of such an universal model that applies to all of these modalities, I think that's a good sign, because that means that like all the improvements will be kind of concentrated, which would not have been there if you would have like ConvNets for vision and LSTMs for language, let's say.
Yeah, that makes it absolutely easier in the practical side of things. And a big part of this, the success of these models is their size, right? So one of the trends that's been happening also is this mixture of experts technique to scale models to, you know, the next order of magnitude. And in this space, there's been this paper from Microsoft, DeepSpeed. What do they propose, Jakub?
Yeah, so DeepSpeed really is this very powerful and kind of widely used framework, more and more adapted framework to train, do distributed training across a large cluster of GPUs. And one of the sort of big achievements they did was this Megatron Turing model, which is actually a dense model. So it's a 500 billion parameter dense model. But now, recently, they also added support for mixtures of experts. So mixtures of experts are kind of sparsely activated models, and you can much more easily distribute them over a cluster. And that means you can go into the kind of trillion parameter regime without all this communication overhead. And well, what you see in some of these figures is that they really made it like, you know, 4 to 10 times more efficient with MOE. So that's impressive. And more on MOEs. This is one you picked, right?
Yeah, exactly. Well, I just added this one because this was, I think, the couple of days ago. There had been some papers earlier about scaling laws for language models and these kind of large models. And I found it kind of interesting that they just released DeepMind this on the mixture of experts case for
yeah,
these
that's
models.
very interesting. Like how does the scaling compare to dense models and stuff?
Yeah, exactly. Yeah. And I just want to say I really like this comparison of this paper on MOEs, because I feel it's a kind of a good example of how much you know, implementation complexity and pragmatism sort of affects you know, what models are published and all of these, because MOEs are apparently quite a pain in the ass to you know, train and use, and probably even if they're much better and a lot of things, until they're not very convenient to, you know, implement and train, they're not gonna it's gonna be hard for them to become as popular as their counterparts, even if they're more efficient and faster learners.
It's still a bit of a rich man's problem, I think. So I just today I got this paper in my recommendation, which is kind of the poor man's version of dealing with this stuff. So it's this paper called Harmony. It's also from Microsoft Research. And in the background, you see some of the related work that we found. But basically here they're dealing with the simple fact, which Marzi knows too well, that when you try to put a too large model in a limited GPU memory, and you don't have this sort of supercomputer, then you run out of memory. So one approach is to do swapping between CPU and GPU memory. And these guys, the Harmony paper, really show like a huge improvement on the swapping efficiency between CPU and GPU memory, which means you can kind of arbitrarily scale models to utilize GPU. interesting.
Yeah, that's very nice. I have to check it out.
So, Sergi, you always like pictures.
Yeah, quick, more fun one. These just saying guns are going out of fashion because I feel like in the computer vision image generation sort of space, there's a lot more talk these days on diffusion models or VQ VAEs, like I've mentioned before. And this one was a paper, I think it's about a month or two old, from OpenAI, where they do text guided generation, which is always a very, I think that, captures the imagination of people, and it's kind of fun to look at. And you can try, sort of OpenAI open sourced a smaller model that you can try on and you can find on their GitHub page. And that's
if you want to get into diffusion models, there's a link here. I will share it later. Kind of intro to diffusion models. It's a pretty cool framework. And other stuff on GitHub.
Yeah, this computer vision library, you were just mentioning how important it was for things to fit in memory, right? I think that this library also tries to tackle that, showing that you can also be really fast without loading into memory, right?
Yeah, so what they show is that actually, if you use this library, you can kind of fill your pipeline much better, and it makes like also a huge, I think almost 7-8 times difference on some training processes in speed. And it's like people always say, it's just one line of code, just change this. So,
there's always some fine print. Yeah,
I think we're wrapping up.
Yeah, we're wrapping up.
Just want to mention this big open source announcement isn't actually not available yet. So it's going to be, it's from Eleuther AI. It's this kind of hackerish band of AI researchers who want GPT to be open source, and they're making their own. And so they had this GPT-J, which was 6 billion parameters. Now they're upgrading it. They're actually using, I think, deep speed to train it, and they're upgrading it to 20 billion. It's going to come out next week, Tuesday. So if you want to replicate Marzi's new paper, but not pay $1 million, maybe this is your chance. And AlphaCode also on GitHub, right?
Yeah, exactly. This was a pretty, I mean, you already mentioned it before, this competitive programming model from DeepMind. What this made me think of is, I mean, Jakob, you can probably speak to this, but I feel like historically there's been, if you look at the decades of AI, there's been sort of a like humans have had a bad intuition at what problems were hard for computers to solve. And people used to think that chess would be, required computers to be smart. And nowadays we think that's stupid. And people thought that, driving a car would be relatively easy. And it seems like it's
playing soccer.
Yeah, playing soccer as well. So that made me think maybe coding or other problems like math that people think are hard for computers, maybe they will prove to be simpler than we thought.
Yeah.
So I guess that's
I think I think it's a really like a new, like prompt tuning is a new paradigm, like writing codes to do something and then dealing with the output of that is another new paradigm which is coming.
So yeah,
one thing I wanted to add was I think the AlphaCode is interesting if you see how many modifications and small hacks that they had to do to get to the average human performance as well, like different like ensembling, clustering, like all of these that each of them contributed. So that's also a good indication that a lot of existing models, you still can get them better once you do these.
And not everybody's so impressed. So I saw a tweet by Dimitri Badenau, the author of the sort of self-attention transformers stuff. And he said, well, I've been in competitive programming for many years, and this like beating 50% of the people is not competitive. But he was still happy with the paper. So wrapping up, so we celebrated 5 years of PyTorch. So what's the next PyTorch? Well, I don't know if you guys have heard, but it's not that big yet here in sort of in research publications, not mentioned so much. But we just want to draw your attention to this framework called Paddle, which is like the Chinese answer to PyTorch. And with that, companies like Baidu and Ali and Chinese scientists are training these super large models as well for computer vision and multimodal and language models, actually on much smaller clusters than what Facebook just announced. So yeah, I think something to keep an eye on, Paddle. And while we're in China, we want to close off with today is the starting ceremony of the Beijing Winter Olympics. They have no snow, but they will make snow. So
yeah, they have made it already. Yeah,
lots of snow machines on photovoltaic cells. So who knows? Yeah.
Another paradigm shift.
Are you gonna watch, Sergi?
I hope to watch some of it, although the schedules are not the best. But I hope to watch some.
Yeah. Marty, are you into skiing and skating?
Not really, but I do wish that we get some of these snow machines here in Amsterdam. It doesn't feel like winter.
Definitely better than what we see now out of the window. So thanks for joining us for this monthly show. And we hope you learned something, and we hope you're gonna enjoy the Winter Olympics, snow or rain or sunshine or wherever you are.
And we'll see you next month.